To do more complex circuit design, first we're going to talk about binary numbers and what they really represent. So binary numbers work just like decimal numbers, except the base is 2 instead of 10. So normally when we think about numbers, we think about the ones place. This is how they taught us when we were kids. The ones place, the tens and the hundreds, and so on. And then if you want to figure out what a number is, you would take 5 times 10 cubed, which is 5,000, 2 times 10 squared, which is 200, plus 3 times 10, which is 30, and 1 times 1. So this will be 5,200s, 30, and 1, all added together. So in the same way, we can figure out what a binary number is in decimal. So for example, if I had 1101 in binary, then I could compute what it is in decimal by adding the places. So this is the 0th place, 1, 2, and 3. So we take a 1 times 2 cubed. We add that with 1 times 2 squared. We add that with 0 times 1, 2 to the 1, and 1 times 2 to the 0. And that gives us 8 plus 4 plus 1, which is 13. So let's do another example. Another example is if I had in binary 0, 1, 1, 1. Then this 0 is the 2 cubed place, but I don't have any. It's just 0 times that. So it would just be 2 squared plus 2 plus 1, which is 4 plus 2 plus 1, which is 7. Okay, that's how we represent numbers in binary. So if you want to figure out what a binary number is, you can convert it into decimal by multiplying whatever's in the place by what that place stands for. So let's try binary addition. Okay, and let me try not to confuse you. We've been talking about ORs as pluses, but they really have represented ORs. But now I'm going to talk about addition like real arithmetic. Okay? So if I want to take two binary numbers, like 1 and 0, and add them together, what will I get? 1. How about 0 plus 0? 0. What 0? How about 0 plus 1? 1. And 1 plus 1?
0. 0.
It's 2, right? How do we write 2 in binary?
1 0.
1 0. In other words, it's 0 carry a 1, right? So if I had more columns, I would carry the 1 instead of writing it right next to it. Right? So let's do some bigger binary problems where we have more than one column. Y'all are smart. Let's do an even larger one. Okay, so we're going to do just like we do addition with decimal numbers. We'll start from the right and go to the left. So we add 0 and 1, and we get 1 with no carry. So the carry is a 0. And then here we add 0 plus 1 plus 1 is 2, which is a 0, carry the 1, right? And then 1 plus 1 is 1 plus 1 is 3, which is 1, carry a 1, right? 1, carry the 1, and the 1 falls down. So this is our final answer. The other way you could figure it out yourself is to write this one in decimal, which is 6, and this is 7, and this should come out to be 13, and that's how you can check your answer. And we actually did do this, and amazingly enough, that was by accident. I came out with 13. Okay, let me teach you a little trick for doing binary addition. Because sometimes it's confusing, that 1 plus 1 is equal to 1, carry a 1. Okay, but I know that you know how to do addition really well with regular decimal numbers. So I'm going to teach you a little trick, and the trick is this. The trick is to change 1s into 5s. So let's redo this same addition but change the ones into 5s. And then at the end, I'll change the 5s back into 1s. At every point, I'm always going to change 1s into 5s, and then at the end, I'll change them all back. So here I add 0 and 5, and I get 5. Then I add 5 and 5, I get 10, which is 0, carry the 1, right? But 1s change into 5s. So I get 5, 5, and 5 is 15, which is 5, carry the 1, it changes into a 5. And then I change them all back, and I get 1, 1, 0, 1. Here. Why does the trick work?
So you're dealing with decimal,
You're breaking decimal down into a binary system.
That's right, because 5 is halfway up to 10, right? And 1 is halfway up to 2. So the way the things move between places should work the very same way. If I do half of the base in decimal, it should work the same way as adding in binary. That's why the trick works.